Yeah, good morning, good evening, wherever you are. And thanks, Anurag and Alan Black, for setting up this workshop. As you said, Alan, I do feel that there is quite a bit happening in the NLP space, and I think speech, I think from a social good perspective, I think we need to talk more about. So thanks for putting this together. So as Gopala said, I'm a researcher at Microsoft Research, but I'm also affiliated to IIT Madras through a center called AI for Bharat. So, of course, Bharat here is an ancient name for India. So it's really, how do we do AI for social good in the Indian context, right? So it's a special center. I'll spend also a couple of minutes talking about what that center is. The title is chiefly called towards ASR for the next billion users. But the truth is that India is a large country, and we have many, many languages. And there's so much more to be done to get AI in the state-of-the-art way it is working in English and Mandarin to many of these languages. So I think there is truth to this particular statement. Right? I'd like to first start off by acknowledging many collaborators, some of whom are mentioned here. These are folks at AI for Bharat. Tahir and Kaushal are two PhD students who have been driving part of the work. Abhigyan and Gokul are research fellows at AI for Bharat. Interestingly, AI for Bharat is set up as part academic, part startup kind of a place where we attract both students but also people who just want to come and from an engineering perspective look at these tools. And we have Mitesh Khapra, who's a faculty at IIT Madras, and Anup is a researcher also at Microsoft Research. Right, so a bit about AI for Bharat. It is, as I mentioned, an initiative that is housed at IIT Madras. And it's got, interestingly, support from a bunch of people. The first point, there is Government of India as part of the Bhashini project. I think this may be of relevance to people on this call to look at what the Bhashini project is. It's actually a project that was sanctioned in the annual budget last year, but it's actually one of the largest efforts made by the Indian government to support Indian language AI. Right. And one of the key pillars there is to build lots of data sets and put them in the open source. So I think folks might find that interesting. I think over the next 12-18 months, you'll see quite a bit of output coming, not just from us, but all the partners of the Bhashini project. Then we have support from philanthropy and I would say people who built digital public goods in India. So the mention of Nilekani is here. So Nandan Nilekani is sort of the poster figure behind things like Aadhaar and UPI in India. Aadhaar is an ID system that, I don't know, more than 1 billion people use. UPI is a payment system in India, which sort of has displaced credit cards and made it easier and cheaper to transact. So Nandan Nilekani has been behind this. And of course, Microsoft has been part of it, and also CDAC, which is a body that is responsible for compute infrastructure in the government, has been lending us lots of GPUs. We're also collaborating with folks like NVIDIA and Google Research. So just quickly, the mission statement of AI for Bharat, I just wanted to put it out here because some of you might like to see what we are doing beyond speech as well. So our mission is to bring parity with respect to English in AI technologies for the many Indian languages that there are, but do all of this in the open source, right? So we want to have open source contributions in data, models, applications, and also we have some responsibility to kickstart an innovation ecosystem because we are housed in the academic setup. We have some neutrality to be able to attract folks from different organizations and see if we can enable an innovation ecosystem, right? So that's broadly what we are trying to do. But the key thing is open source. Everything that we do is on our website, is on Hugging Face, GitHub, etc. Right? It's pouring quite heavily here in Mumbai, so I hope it's not disturbing. There's not a background audio that's disturbing. Okay, cool.
It's good.
Yeah, so this is a screenshot from our website, the kind of things that we do. We are fairly broad in our scope. So we do work in translation. We've been releasing state-of-the-art translation models, data sets, transliteration, speech recognition that I talked about. We're also doing language modeling. We are trying to create language generation models, hopefully get to Indic GPT, etc. We also do quite some work in sign language. So India has a interesting sign language as well. It's of course a visual medium. So how do you recognize signs as people are signing? And then we also build a few applications. The last row there is for applications that are being built. We build application for language work. You need to create data sets. Creating data sets is is hard. So we built a tool that can make that easier and cheaper, etc. We built a tool called Chitralekha. I will show this because this is related to ASR, and then we are also doing something on translation. The last one there, Anuvad, is actually a tool for document level translation, which is used by Supreme Court of India to translate judgments, right? Supreme Court of India, of course, the highest court in the country. They would like to make the judgments accessible to people, but they would like to do it in a specific way. Legal language is very specific. So they use our tool to translate it and then edit it on top and so on. Yeah, so we'll be happy. If there are people who would be interested in AI for Bharat, we are about a year old and are looking for collaborations, looking for people to support, to collaborate, etc. So please have a look at the website. Okay, on to the talk then. Really a talk in 3 parts. I just very briefly talk about some thoughts about data, models, and applications, and how these 3 nodes sort of influence each other, informed by the work that we've been doing. Then I'll dive into the main part of the talk, where I'll talk about a few contributions we have made with respect to Indic ASR. And Dhwani, Shruti, Karpat are all words I'll explain. And finally, I just spend a few minutes talking about applications that we have been building and what experience we have had deploying this in the real world. Okay, so data, models, and apps, right? So of course, we all know that deep learning models require huge amounts of data. So there's this arrow from data to models. And if anything, over the last 5-10 years, this arrow has become much thicker. We want so much more data to be able to train state-of-the-art models. What was based on rules and based on insights earlier now is driven by data. And one way to ensure that no language is left behind is to have enough data for each language, right? This is something that we all understand well, accept, and are working towards. But one thing that may be relevant, and I will touch upon in one of the parts of my talk, is that not all data is equal, right? Whether it is in terms of the availability of data, the quality of the data, and the cost to even acquire or to capture it, right? And this is important because sometimes we think of data requirement as only being requiring high quality supervised data, but there could be other kinds of data which are cheaper to acquire, maybe in much larger volumes, and they are also helpful, right? But we have to balance out the quality and volume issue. Sometimes taking too much noisy data leads to unexpected outcomes. So I'll talk a bit about that part. So data to models arrow has this particular nuance. Right? The other way is also interesting. It seems like, and again, I'll illustrate this with one of the works we have been doing. If you have good models, if you somehow bootstrap building of good models, then this may help create more data. Right? And this, of course, not a infinite positive loop, but it does tend to at least push accuracy of models a few notches by being able to mine more data based on the quality of models you already have, right? And I'll talk about this as one of the contributions we have made. The other thing that is also obvious is that if you have accurate models, you can deploy them in the real world in applications, and that leads to use of these models. That's also well understood. But what we realized, again, given the position at AI for Bharat, is when we try to deploy these applications, a lot of interesting use cases and a lot of interesting requirements on the models showed up, right? For instance, what we may look at, for example, word error rate and obsess about reducing word error rate. But in the real world, people might want something very different. And that may help us shape how we do model development, but even how we collect data, right? So I'll talk about our learnings from that end as well towards the very end. Okay, so let me go on then to our experiments with ASR and try to highlight these 3 things that I have brought out, which is not all data may be equal, that we may want to use the model itself to collect more data, and finally, how can you inform model and data development based on applications. So the first thing I want to talk about is the Dhwani data set. This is something that we did last year, and Dhwani here in Sanskrit means sound, right? Sound in general. Of course, like Professor Black was saying, trends are getting set up in computer vision and NLP, and they tend to come to speech in a while. So self-supervised learning has been around for about 5 years, and we are all familiar with models like BERT for language modeling, natural language modeling. And of course, similar questions have been asked over the last 2-3 years in the speech space, which is, can we self-supervise and learn a sort of audio model, right? And we attempted to do this with not much technical innovation, but really figuring out what works for Indic ASR. And what we did was we sort of took help of a lot of language experts and identified several sources of openly licensed content in Indian languages. So you can see here a table. There's language, and you can see that there are about 40 languages, quite a long list. So just a bit on the landscape in India. We have about 22 Indian languages which are recognized as scheduled languages in the Constitution of India. So when there's official documentation, etc., these 22 get called out. We have roughly 10 languages which major commercial companies tend to want to support, right? But the real list of languages and dialects is in the hundreds, right? So that's the kind of spread that we have. And what we did was to take these 40 languages and take the help of language experts and collect sources of openly licensed content. And in total, it comes to about 17,314 hours. You can see the number of hours per language mentioned here. There are two columns. There is YT for YouTube and NOA for News on Air. These are the two primary video repositories that we took. And you can see the number of hours. For example, Assamese has 667 hours from News on Air and 176 hours from YouTube, right? So this was itself an exercise because we were very concerned with a few objectives, right? We wanted to release the data in open source. We wanted startups, enterprises to be able to build on top with MIT licenses. So that required us to be very careful on the licensing. We also were conscious of taking a variety of domains. We had a domain spread and we wanted to make it diverse. We, of course, didn't want profane content, PII, etc. So we did this bit consciously. And of course, we want to contrast this with market rates of collecting label data in India. So we are quite a bit in this effort now of collecting data, and we understand how the market dynamics works here. Just for your understanding, if you wanted to collect an hour of labeled speech data, that's about 10,000 rupees or about $125 US, right? So we could scrape 17,000 hours of openly licensed audio data with the engineering effort, etc. But the cost in terms of label data is so much higher. Just putting that in perspective. So what you could do is you could then train a speech model, and Facebook has shown how you could do that with the wave to vec architecture, which is by now quite popular. This is already about 1.5-2 years back, and we trained a multilingual wave to vec with the Dhwani data set. And then what you could do next is, of course, visualize what this self-supervised model is learning. Essentially, it takes pieces of audio and tries to compute representations of them in a quantized codebook. And one can use that quantized codebook to understand what it's trying to represent. And here is the TSNE plot of the representations of audio pieces of different languages. And as you can see here, there is Malayalam here, Telugu here, Tamil, Kannada. These are the four Dravidian languages of South India. They seem to be batched up. And if you think of something like maybe here, Bhutia and Lepcha, these are two languages spoken in Sikkim in the northeast of the country. And they are, as you can see, quite far away. So similar languages tend to get similar representation. So you do get a sense that this model is able to figure out something about the language families and relatedness between languages, right? But the primary outcome is to be able to fine-tune these models on label data and create ASR models, right? And the hope is that, of course, because you have done this pre-training on 17,000 plus hours, you're able to fine-tune on smaller amounts of ASR data and improve the accuracy. And we have been so far looking at monolingual models, but one may also train a multilingual ASR model. And our experience was that multilingual fine-tuning was not as effective, right? So the transfer across languages during fine-tuning was not as effective, but the pre-training phase or the self-supervised learning phase we did in a multilingual way. And just a bit of quick results. If you look at the first row, which talks about M0, no pre-training. These are WER numbers, so lower is better. And the columns are actually benchmarks. So there's a benchmark from MSR, there's a benchmark called MUX, and there's a benchmark OpenSLR. By the way, there is need for more benchmarks to be created, and I'll talk a bit about that. We have done some work, but there's much more work needs to be done to create benchmarks. The first row, M0, no pre-training, tells you what a wave-to-like architecture would give you when trained with all available data as evaluated on these benchmarks. And you can see, for example, for GU Gujarati, it is about 46. But then after a bunch of things that we did, including, of course, using our data to pre-train, you can bring that down to about 11.9, right? So, or if you take the, I don't think I have an average number here, but if you look at, for example, Hindi, 48.1 on the MUX benchmark, and you can bring that to about a single digit, to 9.5 number with all the variations, right? So, I guess there's more work to be done here, but it's almost clear that if you could train language models, which is, by the way, possible, or speech models, which is, by the way, possible on a much more diverse set of languages, because getting audio data, even in dialects, etc., is possible. You could start from that and then fine-tune it. And there is promise in getting better models because you've pre-trained it. Okay, so that was Dhwani data set. I mean, I can take questions here because I'll be switching context. Maybe I'll just pause for about 15 seconds and see if there are any questions.
I have one. So creating data sets is awesome and it's challenging. But can you talk a little bit about what metadata it is that you're storing for each language slash, yeah, what can we query this for?
Good question. So what we have done so far is we have taken sources of, we've taken videos, right? And we've extracted audio from them. So the metadata that we have is, of course, the source URL from which we have taken this data, the domain, whenever domain could be inferred by those collecting the data. And we have a domain, let's say, set. By the way, here I should mention that as part of the Bhashini project, we have been working with the government to standardize metadata. Right. So, for instance, when I say domain, right, of course, you could have a different way of defining domains. I could have a different way. So we have tried to work and try to create some specs on how this metadata could be enumerated and thereby standardized things. So we have a list of, I think, about 20 odd domains listed. So under that scheme, we also note down for each video the domain if you could infer it. And that's it. I think this is all we have in this particular data set because there are no labels. But we do know we can certify that there's no profane content and there's no PII. That's what we have.
Yeah, Judith, you can go ahead.
Thank you. Yeah. So Judith Bishop, I was previously at Appen for 17 years, and I oversaw the linguistic resources creation for the IAPA Babel program, where we worked on was Tamil, Bangla, Assamese, and Telugu, if I'm remembering rightly. I was just wondering if you'd come across those, because those are available on LDC. Those are interesting resources possibly for this program.
Right. So Judith, sorry, I couldn't fully get your question. Some of the audio is a bit low, but you.
Sorry, a bit far away. Sorry, it's maybe not so much a question as a comment. I was just wondering whether you would come across the IAPA Babel program resources for language packs there's 4 of these languages: Tamil, Bangla, Assamese, and Telugu, if I'm remembering rightly, with resources for ASR creation and also benchmarks, presumably, for keyword spotting as well as ASR performance. So yeah, I was just wondering whether you'd come across those, because I found that they're kind of hidden in LDC's catalog and not everyone's aware of them.
No, actually, no, and so I'll be happy to look at that and see how we can leverage that, right? So I can reach out to you offline and get connected. But this is one challenge, right? There are so many pockets of resources. It's hard. There was an effort made about 2 years back to aggregate all available resources into a report, right? And this is by GIZ from Germany, and we have tried to follow that. We try to always look at that as sort of the source of truth, but there's a lot of other efforts. So we'll be happy to get connected and understand.
Yeah, terrific. Yeah, connect afterwards. Okay.
Any final question?
Oh, so Tanvina, you can unmute yourself, or yeah, I can read that out. So the pre-trained model is at 16 kilohertz, and what kind of data is it, telephonic or otherwise?
Yeah, excellent question. This is one of those findings that we had when we worked to deploy our models. It's very clear that in India, you have to deploy models at 8 kilohertz, right, which is telephony data sampling rate. What I showed you here is all digital data. I mean, it's all data from video sources, which are usually 16 kilohertz. So what we do is we augment the data, right? We downsample it and upsample it so that we do have a representation of telephony-like data. And we found that that was actually necessary to be able to train ASR models, which can then work for 8 kilohertz data. So the way it works is you have 16 kilohertz data, you take parts of it, and you subsample it and then upsample it. And when you do inference on 8 kilohertz, we also upsample it and do it in 16 kilohertz. And we did some experiments on that. This is not published work, but just this little trick of downsampling and upsampling narrows down the WER errors on 8 kilohertz from something like 3 to 4 points to under 0.5 points, right? So there might be other things that we may do specifically for telephony data, but this upsampling, downsampling already was quite effective. All right, so let's move on then. So this was the Dhwani data set, and all the resources that I'm showing here are open source. So the pre-trained data is open source. It's of course openly licensed. Of course, the models that we've created are also open source. Let me move on to the second one, which we call Shruti Lipi. Dhwani meant sound. Shruti Lipi is an interesting word itself. Shruti means also sound, and Lipi means text, right? So it's really sound and text together. So here the point is, of course, self-supervised training helps, but we need more label data. That's quite clear, because if you look at the table here, maybe Hindi is single digits, but many languages, for example, Odia, my mother tongue, is at 20.6, and that's a very large WER. We can get to sub 5 WERs in most state-of-the-art models, right? So we definitely still need much more label data. It's not enough to depend just on self-supervised training. So what we did was we really looked for, in our effort to collect data, as I was showing you there, we had a column called NOA, which is News on Air, which tends to be data from All India Radio. All India Radio is the public broadcaster in India, of course, government backed. But the interesting thing is they have been creating audio programs for over 70 years from many stations around the country. And here is a map of India, and you can see here dots indicating where a particular station is geographically located. And the number on top of it is the number of hours of audio data that has been released by All India Radio. So All India Radio has been active for 70 plus years, as I said, or maybe even more. But they sort of had a program to digitize and archive data for the last few years, right? So in this period of archival, you can see here the number of hours of audio data that have been publicly released. And the color coding here is based on language, right? So as you can see, green, dark green is Hindi, and there are many stations broadcasting in Hindi around north and west, north and east of India. If you come to the south, for example, there is Tamil. There are 3 stations within Tamil Nadu which are broadcasting. Maybe there are 4 stations doing it in Marathi and so on, right? So again, this is interestingly very diverse data from across the country. It's also fairly voluminous data. We're talking about hundreds of hours from each station, but it's a very small sliver of what's actually possible from All India Radio, right? They've been doing it for a long time, but they've just begun archiving it now. And because we have some connections with the government, we are able to access the data. It has now been publicly released, but we did manage to get an early preview. And as you can see here, this covers many regional variants, as I was mentioning, right? So even for Marathi, 4 different stations across Maharashtra is definitely good coverage. And here is the total number of hours of data that have been released. So across all languages, we have 45 stations from which we have data. And this corresponds to news bulletins. So these are actually just 5 to 10 minute news bulletins, and there are a total of about 70,000 plus bulletins, and totaling to about close to 10,000 hours of data, right? So this is the raw data that we had. Now, one would be excited. One would say that, hey, this looks like audio, good quality audio. But there is also, interestingly, the transcript also available. Right, so somebody has actually read out the audio, and unlike, I mean, it's not an extempore speech. Somebody is reading this out from a transcript that's prepared, and All India Radio has chosen to even make that public. Okay. So we were super excited, right? Here's audio, here is transcript. Now we can go build best ASRs around, right, in Indian languages. And that's what we really asked ourselves the question: can we create labeled ASR data from audio plus transcript from this public broadcaster? But it turns out there are many challenges. Again, I'll show you some of these challenges. In this picture, I show you examples of transcripts for 4 stations. Firstly, notice there is no standardization. These are PDF documents, and they have variety of formats. The first one is from Thiruvananthapuram. It's a station in South India, Kerala, and as you can see, there's something written in Malayalam. Then there is some English text to explain what's happening, and then something else written, and so on. Of course, it has some headers and some complex formatting there. If you look at Patna, there are few snippets mentioned in the first, and then there are some details later. If you look at Bhuj, you see the different script, but again, this is just free form text, an entire paragraph. There are no points, there are no bullet points. And Aurangabad with Urdu, again written as a free flowing thing. So first of all, each of the stations have their own templates of writing this document, their own template of what cues are provided to the newsreader versus what they actually say, and also things like some programs have a few bullet points initially and some others not, and so on. So there's huge variation in terms of the format of this document, and of course these are interestingly or unfortunately in India, these are based on fonts that are legacy and copyrighted fonts. So OCR on them is required. It's not a digital PDF where you can extract the text. You don't have the encodings for them, so you have to run OCR, right? So that is the first big problem. How do you extract text from these PDF documents? There are many other challenges. Some of them are shown here. The first one, just there are 4 examples. Let's go through all of them, right? So the first one is music and audio. So it turns out if you look at this particular little audio snippet, so there is some kind of a little bit of a, I hope you can see my mouse. This particular region here is actually music, right? So some audio files have music, some not, and so on. And then there is text, right? So how do you figure out what is music and remove it? That is one problem. Another problem is, as I was saying, OCR errors, right? Because we can't digitally extract data, you have to depend on OCR. And because I didn't show it here, but some of these texts are justified in terms of alignment, some others are left aligned, and actually OCR is not good enough where it can differentiate between things. Sometimes you may get a string of text here without spaces between words, right? And you'll have to figure out what to do with that. Then there might be extra text. So it might be that the newsreader has actually not spoken something that is in the document. Or it could be also that the newsreader has not has said something which is not in the text, right? So both ways is possible, missing text and extra text. And also what is possible is the audio bulletins might have a snippet of an interview or a reporter reporting something, which is of course not captured in the transcript. So there might be entire regions of let's say half a minute or so of some extra audio, which has no correspondence to text on the transcript, right? So these are all the challenges that we had. So the question was, how do we do alignment of this highly noisy transcript document with the audio document, right? And if you could do that, how does that help, right? So basically, this was the pipeline that we had. We had this transcript PDFs. So we had to do OCR and a bunch of heuristics to be able to extract data from that. And we had the audio, and we had things like music, we had external clips and other things. So we had to again do ASR plus heuristics to be able to control for these effects. And once you get the text from one side, the text from the other side from ASR, we had to do alignment. Notice that this is document scale alignment, right? So as I said, these are bulletins and their typical length is between 5 to 12 minutes, I think averaging about 9 minutes. So how do you take 9-minute audio files, even if you assume OCR and ASR work, and how do you align it, right? How do you do document scale alignment, where there might be things that are missing and things that are extra and so on, right? So this was really the problem that we had to solve. And this is roughly what we did. So I'm going to just hand wave and show you what we did in a single slide here. Of course, we use something like an alignment algorithm called, in this case, Needleman-Wunsch alignment. This is a dynamic programming-based alignment technique. So think of it as a way of doing post alignment, but let me just show you what actually we did. So you had X, the raw audio, after all the processing. Then we passed it through a frame level emitter. So you get for each frame here, these are frame numbers, 0001, typically 25 milliseconds. And for all of them, you get a character sequence, right? And then we apply something like a CPC decoder to be able to map a bunch of frames into a single character to be emitted, as it becomes P here. And on the other side, you take the OCR transcript, right? This is the OCR transcript after all the heuristics. And we may, and then we do an alignment. So this little box here is the alignment between P and R. And that we did through Needleman-Wunsch alignment. What it essentially does is tries to find a path between the reference text and predicted text that maximizes some score or minimizes a certain cost, right? And we can define cost of alignment between pairs of characters, and then we can try to find the path, right? And notice again that we are talking about something like 10 minutes. So there might be entire regions. It doesn't show up in this small example, but when you do move vertically and when you move horizontally, as opposed to moving in the X equal to Y line or parallel to the X equal to Y line, when you move vertically and horizontally, you're essentially accounting for missing or extra text, right? And the question is, across such large scales, can you actually align things, right? So we this is what we did, and we applied this to all the languages. Notice here that, of course, you need ASR systems to be already working, right? So from going from X to E, I need an ASR system. So if there is a station somewhere in North India, which is a form of Hindi, which we don't have good ASRs for, then this would be very noisy, right? The X to E would be noisy, and the rest of it would fail. So here is a case where if you have good models, the ability to go from X to E is much higher, and therefore the likelihood of alignment is much better, and you might be able to collect far more high quality data, right? So this is the point about models helping create more data, because notice that places like All India Radio are a continuous stream of good quality data that are coming out there, right? And there might be other such sources as well. And as we keep improving the models, the quality of data we mine from them can also improve. So what happened if when we applied this to all the languages that we had access to, and this shows the amount of sentences that we got out. Also notice that here we have done a sentence level segmentation, right? So we take the transcript, and after you make the alignments, you'll make sentence level segmentations, and then release the data. So what we were able to do is, across all these languages, extract about 6,400 hours of data, which corresponds to 3.3 million sentences or utterances, and this amounts to about 67% yield. And so interestingly, we found ourselves tracking the yield of the data. So from the total data, how much could we align accurately enough? And this was 2/3 of the data we could really align. We felt it was not bad, given that there's so much additional content like music and external clips and so on. So we were quite happy with this. And I just wanted to put that in perspective. This plot here shows all the data that's available for all the labeled data that's available, right, in various languages. The first bar, GIZ, is a report that I mentioned, which tries to collate all available data from academic and industrial sources that are open source. This was a report done in 2021, so it's a bit older, but still relevant. So, and the second bar, there is Kathpath, which is also a data set that we have released, and I'll talk a bit about that later. And Shruti is a data set that I just talked about now, right? So as you can see, though this is mined and likely slightly erroneous data, it does make a large difference to the amount of labeled data available across many languages. For example, in Hindi, we have maybe 500 odd hours of data coming into this, and in the open source, and this particular data set almost triples that amount of data, right? In terms of just data availability. Okay, so that was the data side, but what happens in the model side? And this is just the results for Hindi. And as you can see here, when we did something like a wave to vec architecture, the first row here is without Shruti, and if you use Shruti, we are able to get a 5-point drop in the WER. Not bad. I think getting that kind of improvement is good. I also want to mention that these are the common voice benchmarks, and we've also released some benchmarks of our own. I'll talk a bit about them. But we also tried doing other architectures. So, for example, if you use a conformer architecture, which is gaining more interest these days, then you also see an improvement, but not by much. So that is one thing we saw. We also created a hard benchmark, where we added noise. We did this telephony-based augmentation, like someone was asking, and we found that the improvement is actually larger. So here we get about a 5-point improvement, but here is a few decimal points larger. So we found that it is also more robust, right? So I think we need to do a version of this with much diverse and let's say much far better benchmarks, but at least the confidence we have is that the data set is improving the performance of ASR models significantly. I have not shown this here, but it turns out that one may expect this data to be not very diverse. One may expect that the same speaker is speaking every day on this program. That's not the case. It turns out that different speakers are actually announcing their news each day. And also, interestingly, the language tone is not too formal. So it's really not, it's professional, but it's not sounding very formal, and there is variation in the prosody, etc., as people are speaking it, right? And this is the numbers across other languages. The previous one was Hindi, and we also again see that on existing MUX benchmark, which is somewhat narrow, we do get about a 2 WER improvement, but on the new, much more diverse benchmarks, we are seeing larger drops. Right. So I will pause there to see if there are questions on this segment before moving on to the next one.
I have a question about the data. You sort of just hinted at the fact that it's not overly formal. So even though it's broadcast, it's still reasonable. I assume there's a fair amount of code switching with English and possibly Hindi, depending on where it is. Can you measure the amount, or do you know if your speakers are native Hindi or Telugu Hindi or something different? Do you take that into account?
I see. Interestingly, there is not much code mixing, because this is, though not formal speech, but it's actually it's read speech, right? And it's being read from a transcript. So often they don't, we do have code mixing to the extent that there are borrowed words, right, in the lexicon, right? And for which we don't have good native versions. That exists, but they are not code mixing as one would when you speak extempore. Right? That's not happening. And also, though they are not very overly formal, the speakers are native speakers, right? So they are from that region, and they are trained. So they are native speakers, and they have a good diction, etc. So we didn't really think much about bilingual expertise there, because they all seem to come from that particular place and we're speaking their language naturally.
Okay, thank you.
All right, Judith, go ahead.
Curious whether you did any cleanup of the orthographic variation, so the spelling variation, knowing that there are massive amounts of it in these languages, and even just at the code point level or tokenization level.
Sorry, again, the volume is a bit low for me.
Sorry. I think I need to speak closer. I was just wondering whether you did any cleanup of the orthography, because I recall from work that we've done on some of these languages, there's absolutely massive lexicon reduction you get if you standardize some of the spellings. So I was just, curious to know whether even maybe at the level of the code points or tokenization, whether you've done anything around that to try and improve the word error rate.
Right. That's a good question. I think we haven't done enough there, at least not an orthographic standardization. What we did do, which I'm not talking about it here, but we have a similar effort on the NLP side, where we collected large amounts of monolingual corpora and trained language models. As part of that, we trained standard BP tokenizers, right? And we simply inherited those here, right? But that may not be the ideal thing to do if I reflect on that, because it's much more general text, right? It's much more wider text available from the net, and maybe training tokenizers specifically for the text we have here may help, right? But what we did was take what we had from the NLP side.
Okay.
Right. So Pratyush, I have a question. The first one, the improvements that you're reporting with Shrutilippi, are these like fine-tuned versions of the pre-trained models from the previous module, but now with some supervision?
That is one version of it, right? So the first set of things are of that kind because they're wave-to-wave models, right? Whereas conformer is an entirely different architecture and was not pre-trained. Right?
But the difference between like the first line and the second line in the first one is merely the fine-tuning with some supervision.
Correct. So wave-to-wave, the first row itself is also fine-tuned with existing data. Right, and the next one is fine-tuned with the existing plus Shrutilippi data.
Got it. Yeah, thanks. Also, Vikram asks if you've done anything multitask learning to group languages together. So I wonder. So these are still monolingual corpora, monolingual data sets that you're training on, right? Or is it a multilingual pre-trained model?
The pre-training is multilingual. So far, we have not succeeded in doing good multilingual fine-tuning, right, with the shared vocabulary for decoding. But I think that holds promise. But we haven't done any multitask learning so far. I'll talk a bit about tasks in the next segment, but we haven't done any of that so far.
All right, great. So one last comment. So because you have the blessing of the Government of India and All India Radio, can you prospectively use the text in their raw form before having it be PDF'd and OCR and all the subsequent cleanups?
Yeah, no, the blessings are highly qualified. Right? So that's a very hard thing to do. So I think even getting this data was some access, but now good thing is this data is available online, right? I think getting into the organization and getting their raw data would be hard, but it's about convincing people that this is worthwhile. So we will be at it, right? But what is useful for the community is that the government is a huge source of good quality data, right? For example, if you look at the parliament proceedings, right, across different state assemblies, people are speaking and this is getting transcribed and corrected and so on. And this is valuable data for us all to have access to. And hopefully with the Bhashini project, some of this discussion takes strength. In fact, we have built a platform called Data Dan, right, or data donation to be used within the government for different entities to share data with each other, right? We are a bit optimistic that some things might happen on that side. But this moves rather slowly. Yeah.
Sure, thanks.
All right, so the next part, this is the Kathpath data set. Kathpath, interestingly, is a Kashmiri word. We have Tahir Javed, who is a PhD student from Kashmir. He in fact studied in Srinagar and is now doing his PhD with us. So Kathpath in Kashmiri means chit chat, right? I think that would be a good way of translating it, chit chat. So what we have seen so far, self-supervised learning helps. We also seen that aligning label data helps, but we still need more data, right? I think we will never stop saying that we need more data, but here we need also manually collected data. So what Tahir did along with others is to collect data from different parts of the country. So this is a work that we did in using an app called Karya. Karya means work. It's an app from Microsoft Research, basically a phone app, an Android app that allows you to do language work, things like speak a sentence, works offline, and is very light on the phone, right? So we were able to, as you can see in this diagram, there are little triangles in different places where we collected data from. And in total, we had 203 districts in India from which we collected data and about 1,200 plus contributors, right, unique speakers. I would think that we were just testing the waters here, right? We want to do a much more larger scale of this same effort, but at least we were trying to prove to ourselves that, this is possible at a national scale. And what we did was we collected various snippets of text from our language corpus, and then we put it out for people to speak out. So it's all read speech. It's not extempore. It's not conversational. Just read speech. Read out the piece of text that you see on the screen, right? And these are usually small segments, not more than about 10 words, right? And this is what we collected. Yeah, the language codes on the top, and you can see here, so you have the split between male and female, you have split between, what also happened was, as we did it, we realized that some of the data that we collected initially was very noisy because our data collection guidelines were not robust enough. And so we have a segment of data which we call noisy data, and then there's clean data also, but that also provides us an opportunity to create a noisy benchmark, right? All right, so what you could do, I just sort of like very briefly talk about results from this. So we can take the data set. There's much to be said about the data collection process. I could talk about that if there are interest. But once we had the data set, we could of course train models with it, and you could see that addition of the Kathpat data to our existing data set improves the accuracy of models. So on average, we went from 16.2 to about 14.7 once you add Kathpat to the training data set. But also interestingly, what we did was we released what is called Indic Superb, which is a benchmark, which is a multitask benchmark for Indian languages. We are at this juncture, we are clear that the most important thing that will add value to the space is to have good benchmarks. Benchmarks that are diverse, benchmarks that are very real world, include things like telephony and so on. So we started off that effort. We released Indic Superb, and this has several tasks across 12 languages. Of course, there is ASR benchmark, both noisy and clean. Then there is speaker recognition, speaker verification, language ID, query by example, where you have a query and you find all audio snippets which match the text in that query, and also keyword spotting. So we have released this, taking inspiration from the Superb work done, which is essentially releasing a bunch of speech language understanding tasks, and we've done that for 12 languages, and we hope that this helps further evaluate the models that we are training. Right? Okay, that was a very short thing, but I realized I didn't put a link to the paper, so I'll probably do that once I send out the slides. But this was the Kathpat work. I just want to mention that we are in the process of collecting data across the country, and if there are people who would like to collaborate with us, help us improve the process, etc., give us insights, we'll be very happy to do that. Okay, let me move on to applications briefly. I see that I'm running late. One thing that I want to say is, because of the position that we are at IIT Bharat, we are challenged by people who fund us to also build things that are practical, right? And so I want to show you a couple of things that we have been doing in that front, and actually it has been rewarding, is to recognize how do you take these academic contributions and try to translate them into real world use. This is a video about Chitralekha, which is a tool for subtitling educational videos. I just play that and let that speak for itself.
Chitralekha is designed to simplify translation and transcription. It supports automatic speech recognition in 9 Indian languages. One can simply point to a YouTube video and run our speech model to create automatic transcripts. The user interface has been designed specifically to enable easy transcription by showing audio waveforms and boxes with the transcription. We support translating the input sentences into 11 Indian languages with our Indic Trans model. The errors made by these models can be corrected by manual edits, and that too with transliteration support for easy input.
The Chitralekha app is very helpful for us. We currently have a manual process where data is entered in different Excel sheets and documents. This app makes the workflow much better. We are interacting with the AI for Bharat team to help support these. Thank you.
Once the transcripts and translations are done, they can be exported into standard formats and uploaded in YouTube videos.
NPTEL is the leading education portal in the country for higher education and has the maximum amount of content in technical subjects. Recently, the government has a big mandate for us to translate all this content, particularly technical content, into a lot of regional languages. We are really excited to hear about AI for Bharat's Chitralekha application, which is able to combine cutting-edge AI technology along with a very hands-on usable application so that people like us who run education portals can do translation effectively to translate content into multiple languages. Thank you.
Cool. So that was the
Chitralekha is designed.
Okay. I should just go to the next slide. Okay. Yeah, so that was the Chitralekha application. It's really an application where you can pull in an educational video, transcribe it, and then translate it, translate the subtitles, that is, into many languages. We are thinking of partnering with NPTEL, like you saw, which is something like a government version of Coursera in some sense, where there are lots of courses online for students to take across the country. We are also working with folks who have been doing same language subtitling as a way to improve literacy. So we are excited that it actually can help language learning across the country. But that's ongoing work. I'd just like to spend another minute showing you. So the other thing that we have been doing is to work with folks like NPCI. NPCI is a body that is responsible for payments in the country. And they've been asking us, hey, can you help build a custom ASR solutions, which can do things like entering ID numbers just by voice, right? So it is an interesting application. Let me just change my screen to that and show you how that works. Are you able to see my browser window? Okay, so here, I mean,
oh, not right now.
Not right now?
No. You may need to drag it.
It's on the entire screen. Let me just share it again. Stop sharing. Just 1 second. Can you see it now?
Yes.
Yeah, so here the intention was we don't want generic ASR systems, but we want systems which can really decode in a very specific domain, and in this case, numbers. And it turns out that people say numbers in very strange ways, and we will have to support that, right? So for example, let me just demonstrate how this works. And this is, we have built it for more languages now, but this is for Hindi. And I could say numbers like 1955. So what I said was 1955, which is 1955. And you might say the same number in many ways. For example, you may say 1955, 1955, and so on. And people actually end up saying numbers in various forms. So we have a little model that that supports this. Just doing this, and of course, this code mix. So I could do something like 1955. Okay, so I think it's sort of, this one is not the code mix model, but there's a code mix version of this where you could say parts of it in English and complete the same number in Hindi, right? So we have built transducer-based decoders which can decode the number and actually extract things. And you can also say alphanumericals and so on, right? So this was primarily to say how we spent a good couple of weeks building this out. We realized that though we may build these ASR systems specifically, what is of value on the ground may be different. So what we are aiming to do here is to work with the government to make IVRS work completely without you having to key in anything on the phone. So IVRS is big in India. Lots of things happen through IVRS. You call in a number, then you are told, for this press 1, for this press 2, for this press 3, and it's a long song and dance that happens. And the question is, can you enable all that to happen without you having to take the phone off your ears, right? And we are hoping to create a module that will work across 10 languages with code mixing in English and so on, right? Yeah, so with that, I'll just stop sharing this part and come back to my slides. In fact, that was my last slide. So this is, I just wanted to conclude here and say that all the data sets, models, and applications that I've shown are open source, and you can access most of them at our website. And of course, you can also email. Yeah, thank you.
Okay, great. Thank you very much for a very comprehensive talk. All right, I suppose we have time for some questions.
I have a question. Do you see your target users, the people that you're serving, being the end user Indian person, or startups and government institutions that would then integrate the information, both the data and the models that you build, into their own further apps?
Yeah, good question. I think it has to be the latter because we don't have the wherewithal to have a product deployed and running out of an academic institution. Interestingly, there is quite a bit of energy in the Indian startup ecosystem. So a lot of startups are interested. So as part of the Bhashini project itself, about 70 startups have been empaneled sort of to take what comes out eagerly and deploy it on the ground, right? It's a process. It's not easy. It's not like if there's something on GitHub, they would be able to take it. That is why we are going a little bit extra. We are doing a little bit extra and building some reference applications, reference use cases, and so on. Even things like model fine-tuning for a domain is not obvious, right? So I guess we're in a phase when we'll do a little bit extra, but hoping for them to take it and run with it soon. Right?
Okay, thanks.
Judith, please go ahead.
Yeah, I guess following on from Alan's question, perhaps I'm curious to know what the most critical use cases might be. You mentioned health and education at the start, and we've seen how automatic transcription can be used for education. But in the health sector, for example, do you see a way into that, and where you would start in terms of deploying some of these technologies in the healthcare sector?
Yeah, no, good question. There are. Again, our background is only working with the government in some places. So there's quite a bit maybe happening in the private sector also. But what we do know from the government, there is a service called e-Sanjeevani, which means online health in some sense. And they are interested in building a first level support, automated support, right? So they would like people to be able to call in and say, maybe, I don't know, I have a stomach ache or something like that. And there's some triaging that happens fairly automatically. And then you're able to pass it on to experts, right? After a while. So this is very early thinking, but I guess what is emerging from these discussions is we need to think of the full stack of an ASR system embedded within a broader conversational system, right? And how do you ensure that ASR systems can be designed to, depending on the context, do well on certain subsets of words and so on. I think that seems to be a common template. And how do you do that effectively is one thing. The other thing, of course, is code mixing. That seems to be super important. I mean, in India, almost everybody takes code mixing for granted. So there's a lot of that happening. And our initial efforts to model building simply failed because we didn't consider code mixing. And there's no good data set, there's no good benchmark. So I think a lot more needs to be done to bootstrap that. So while healthcare may be one of the domains to get into, I see these technical problems, right? Being able to work in a domain, being able to do code mixing, and then also contextually performing well on certain words, etc.
No, that's very interesting. I guess also in terms of health, the diversity of the speakers, like older speakers, as well as the full range of demographics. Yeah, thank you.
Yeah, but Tanvina, go ahead.
Hi, Pratyush. Thank you for the talk. It was really interesting. I don't have a question now, just a comment. I think it's really a need that all this data and things are, made open source. Yeah, now it is. But I see the same thing we have done almost 4 years back. So I come from a startup in India, which was it's Cognate, and I have worked for 4 years, and I have done the entire same thing, collecting. As a team, we have done the entire same thing. Like we had all these crazy use cases that come for Indian languages, and we had in 2017, I think, zero data for Hindi. And that's when we actually have manually did all this collection of all India radio script to the broadcast, clean up. We have done all that manually. So I think it just, most of the efforts have been overlapped. And it's just many of them might have already done a similar process. So I think it's really necessary that everyone just collaborates and reduces the effort. Really, we have done so much. I feel like either one could have benefited if one could have shared at that time. I had a more open platform to even say that, yeah, we are collecting. So it's really a need of that at least we start sharing.
Yeah, I fully agree. I think a lot of work is happening. based on real world requirements, right? I think you responded to a need that you had and you did this. One thing that I can say is we are working with the government to create what is called the what is being called ULCA, ULCA, for Unified Language Contribution API. And the intention is that these kinds of things, right? Of course, it's only, it has to be open source work. There might be a company that does something or a startup that does something for specific internal needs. But if you can open source anything, we are trying to create a standard way in which data can be contributed and to be collated across all these contributors and standardize the metadata, as I was saying earlier, and then make it available for people to download, right? So I think we haven't done a good job of that, but I think now things are moving, right? So would be happy to connect you to that. And if there are sources that you have collected which can be open sourced, we can also retrospectively add them.
Yeah,
Great.
thank you.